Only you. Once they are hearing, you know, wahala. You can start with what you are doing.
Hello, please. Indicate. Hello, indicate if you can hear me, please. Indicate if you can hear me. Hello, please indicate if you can hear me. Indicate if you can hear me, please. So that we can get started. Sorry for the delay. I had issues with my mic and the rest, so please indicate. If you can hear me, indicate. Indicate. Indicate if you can hear me. Indicate if you can hear me, please. Please indicate if you can hear me.
One said thank you. That means they are hearing you.
Please, can we start now?
Ask them if they can hear you. If that one they play, they say they hear. That means they are hearing you.
Can we start now? Can we start now? Please indicate. Indicate so I can get started, please. I'm not hearing any response from you guys, please. Indicate. Indicate so we can get started. Indicate. Indicate so that we can get started. Oh. All right. If you are there with me, we've been doing our Jamb series, so I will continue from 2017 where we stopped. 2017, number one. If you have your Jamb series, just open to your 2017 Jamb series. Question number one. Can you hear me? Please, can you hear me? Indicate. I'm not getting any response from you. Please indicate.
I can hear you. No one has said anything.
All right. Now I will read the question so that it will be easy for those of us that don't have it at home. I'll be reading the questions and I'll be solving it directly here. All the solvings and everything, you'll be seeing it from here. All right. Question one. Question number one. The flame used by welders in cutting metals is. Question number one. The flame used by welders in cutting metal is A. Butane gas flame, B. Acetylene flame, C. Kerosene flame, and D. Oxyacetylene flame. The answer to that question is D. Oxyacetylene flame. Number two, at room temperature of 300 Kelvin in figure 1, A, Y is twice as soluble as X. You can see the graph. There's a graph there. You can see the graph. They said A, Y is twice as soluble as X. B, X is twice as soluble as Y. C, X and Y are soluble to the same extent. D, X is 3 times as soluble as Y. Now the correct option, when you look at it, you can see from the graph X and Y, there's just 2 centimeter difference between X and Y. So your option there is twice as soluble as Y. Now number 3. Number 3. Number 3. Tetraoxosulfate 6 acid is prepared. Tetraoxosulfate 6 acid is prepared using the chemical reaction XO3. If you can see me, look at it. XO3 gas plus H2O liquid. This gives us H2SO4 liquid. Full stop. This is the equation of reaction. Given the heat of formation for SO3, H2O, and H2SO4 as, now they give us their units as SO3 was given as minus 395 kJ mole minus 1. H2O is given as minus 286. And H2SO4 is given as minus 811. Now, they said respectively, the enthalpy change accompanying this reaction is, now don't forget, change in enthalpy equals to what? Change in product minus what? Change in reactant. Now from here, this minus 811 is the product. So we say minus 811 minus, now your reactants, you have minus 395 plus minus 286 together. We add reactants together. Now 395 plus 286, that gives us minus 681 in brackets minus 811. Now don't forget, minus times minus would give us a plus, so we have minus 811 plus 681. Now when you minus this from this, we have our answer there would be minus 130 kJ. The option there is B. Number 3, B. Hope we are together. Hope we are together. How many? Okay. Hope we are together now. Please, are you getting me? Are you getting me? Move on. All right, question 2. At room temperature, which is 300 Kelvin, in figure 1, you can see there's a graph there. It's a solubility graph. A solubility graph. There's a graph which is a solubility graph there. Graph, you can see solubility, and this is the temperature. Is a curve. Okay. Now they said figure 1. The options are A, Y is twice as soluble as X. B, X is twice as soluble as Y. C, X and Y are soluble to the same extent. And D, X is 3 times as soluble as Y. I said the correct option there is B. X is twice as soluble as Y. Are we okay now? Okay, let's move on now. Let's move on. So, hope you got number 3. Hope you got number 3. All right, let's go to number 4. Let's go to number 4.
Continue with
Number 4. Now here's a question for number 4. In two separate experiments, 0.36 gram and 0.71 gram of chlorine, 0.36 gram and 0.71 gram of chlorine combined with a metal X and Y, combine with a metal X to give Y and Z, is showed that Y and Z contain an analysis shows that Y and Z contain 0.20 gram and 0.40 gram of X respectively. The data above represent the law of now here we said 0.36 gram, okay, and 0.71 gram of chlorine combined with a metal X to give Y and Z. Analysis Z contains 0.20. So let's say this one is Y, this one is Z. The is Y, that one is Z. So 0.36 gram of Y produced 0.20 gram of Y. Then 1 gram of Y would then produce what? Produce Y. Why this other one? 0.71 gram of Z produces 0.40 gram of X of Z. Now 1 gram of Z would produce what? Z. This would give. Can you see? Please always respond so that we can move fast. Can we see the solvings now? The option to that number 4 is law of multiple proportion. Don't forget, the law of multiple proportion states that when two elements A and B combine to form more than one compound, the element A which combine with a fixed mass of element B are in ratio of small whole number. Don't forget that. Okay? All right. Now number 5. Number 5. If an element X of atomic number Z, if an element X of atomic number Z, okay, and mass number Y is irradiated by an intense concentration of neutrons, the relevant nuclear equation is now you can see what they're trying to let you know. Don't forget, we talked about atomic number and mass number. Atomic number is the one underneath, while the mass number is the one what? On the top. So from your question, they said atomic number Z and the mass number Y is up. Okay, now which one is the nuclear here for the neutrons? A, Y, Z, X, 1. Now don't forget its nuclear equation. You've done what they call alpha, beta and gamma ray. The correct option to this is option B. Tick option B for number 5. YZ X plus 1 0. The correct option to it is option B. Option B is the correct option for number 5. Option B. Option B is the correct option. Number 6. Number 6. Are we together, please? Number 6. Number 6. The vapor. Please, are you with me? Are you? Should I proceed to number 6? Should I proceed to number? Should I proceed to number 6? Please let me know if I should proceed to number 6. Should I proceed to number 6? All right, number 6. The vapor density of a gas. The density of a gas may be defined as A. The mass of a unit of the gas. The mass of a unit volume of the gas compared to an equal at 10 atmospheric pressure is placed in a 20 centimeter cube container. Calculate the new pressure if temperature is kept constant. Now from here, V1 was given as 30 centimeter cube at 10 atmosphere. P1 equals to what? 10 atm is placed in a 20 cm cube. V2 equals to 20 centimeter cube. We are asked to calculate the P2 question using the formula P1 V1 equals to what? P2 V2. Okay, now let's place our parameters. That is what? 10 times 30 equals to what? P2 times 20. Make P2 the subject of formula. P2 equals to what? 10 times 30 over 20. This becomes 300 over what? 20. Here. That is P2 equals to what? 15 atm. Option to that number 7 is B. Option to number 7 is B. Option to number 7 is B. Hope you can see the writings. Hope you can see the writings. Hope we are together. Hope we are together. All right. Now I'll go to number 8. Number 8. Number 8. A liquid begins to boil when A liquid begins to boil when A its vapor pressure is equal to the vapor pressure of its solid. Number 8. Number 8. A liquid begins to boil when A at the given temperature. B escaping from its surface. C. Its vapor pressure equals the atmospheric pressure. D. Its vapor pressure is slightly increased. A liquid begins to boil when the answer to that question is C. Its vapor pressure equals the atmospheric pressure. Number 8 is C. Its vapor pressure. A liquid will begin to boil when its vapor pressure equals the atmospheric pressure. Number 8 is C. Number 9. Four elements. Four elements. Four elements. W, X, Y, and Z. Okay? Have atomic numbers 2, 16, and 20 respectively. Which of these elements is a metal? From this, we definitely know, don't forget the periodic table: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and what? Calcium. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, and what? 0. Now you can see they said 2, 1, 2. It is not. Is a transition, is an inert what's it called, element. What's it called? 6. The next one, 6. 6 is not. The sixth element is oxygen, is not. 16. 16, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is on, is not. 20. The 20th element is calcium and it belongs to group 2. So your answer there is 20, which is Z. The answer to that question is